Hello, my name is Rob Reynolds. Welcome to Calculus section 1.3. We're going to review some log properties, and at the end of the video I'll go over some factoring techniques. So the first thing you need to know about logs is if logs don't have a base written, it's assumed to be 10. The next thing you need to know about logs is the definition, and I call the definition a fishhook. You start with the base of the log and you go over to the exponent, because logs really equal exponents, just like addition equals subtraction and multiplication you can rewrite as a division. They're called inverses of each other, and the inverse of a log is an exponent. So this log equals this exponent. And so we're going to start with the base and say it equals the exponent and come back, and that's that fishhook that I'll talk to or refer to. So this 10 becomes the base of the exponent. 10 to the exponent, 10 to the y, is equal to 1,000. And of course that happens when y equals 3. Then we have these three log properties, and it says when you take the log of a product, you can write it as the logs of sums. Quotients go to differences, and I call this the drop-down property, where you drop down that n and make it n times log x. The last one is the change of base rule. So if I give you the log of 5 base 3, most of your calculators have updated TI-84 versions. If not, you can come into the Academic Achievement Center and I will update your calculator so that it actually can type that in for you. But if you don't have an updated calculator, you can use this change of base rule, which means that you can rewrite it as the log of 5 divided by the log of 3. There's a couple ways to type that in, as I mentioned, onto your calculator. If you go to Math and an arrow up twice to letter A, it says log base. Press enter. You could type in the 3 followed by the 5 and actually get a decimal equivalence for this. Another way to do it is to hit alpha y equals. That'll bring up a function key. I can hit the right arrow, but some of you need to hit the window to get over to the function. And then you can see there's a bunch of things that we'll be using here in calculus as well, but for now I'm interested in number 5, and that gives me the exact same way. So again, two approaches, and there's probably more. Everything's under your catalog if you can't find anything. So we'll talk more about how to use your graphing calculators. Please go out and purchase one if you don't have one already. So for this one, I would fishhook this, and 3 to the y is equal to 162, but there's no way to write 162 as a base of 3. So either you could leave your answer as the log of 162 divided by the log of 3, or you could punch that in. Actually, you could punch this in as well using that new technique, but it's the same thing as just typing in the log of 162, closing that parentheses, and then dividing by the log of 3. Either way, your decimal should turn out to be around 4.63. So approximately 4.63. And then this last one, you need to know that this is pronounced natural log. It's actually, it's interesting. This is the log and this is the natural, but we flip those around and say natural log. And that just means it doesn't have base 10. We assume that if there's no base written, that it's base e. And e is a number like pi, 3.14, but e is 2.7, 1828, 1828. It's mostly used for interest and banking, pushing things to the limit. We'll talk more about e and its properties later. But in this case, e to the 55th is x. And again, you could type that in and get a decimal, or you could just leave it e to the 55th. Using some log properties, starting with the parentheses, the log of a plus the log of b is the log of a times b. So 2 times 4 is 8. And over here, I'll do the dump up method instead of the dump down method, and that becomes the log of 8 squared, or the log of 64. And then I do another property and say, oh, the log of a minus the log of b is the log of 64/8, which is just the log of 8. Now be careful, a trap that sometimes students get into is they see this division and then they all of a sudden think that they could either write that as the log of 64 divided by the log of 8, which is wrong, or they think that they can start writing this as maybe the log of 64 minus the log of 8. Both of those are incorrect. this one is actually, I hope you recognize the log of 64 base 8, where this one is what we actually had when we had log of 64 minus a log of 8. So don't get down this trap because they look similar. Just because you see a division sign, you have to figure out if I'm talking about the second property. This guy, students get mixed up with the change of base rule. So try to keep that straight. For the next example, I would use the dump up property a couple times and rewrite this as the natural log of 12 plus the natural log of 4 cubed, or let's just say 64, minus the natural log of 6 squared. And let's work this left to right. This is the natural log of 768 minus the natural log of 36, and then we hope and pray that 768 divides by 36. But it doesn't. So either we just leave it, or you could punch that in the calculator and get something close to 3.06. You should recognize the answer in both forms. Here we go. The log of 12 minus the log of 3 is really just the log of 12 thirds, which is the log of 4. And you may think you're done. However, you can fishhook this. 2 to the x, or 2 to the what power, is 4, and you may recognize that as a 2. So always try to simplify your answer. The burning question is, what happens if you would have left your answer as the log of 4 base 2? And I might have taken off a point because you can simplify that. That's like leaving 2 fours. So I prefer you to always have your answers in simplified form. Let's do the dump up method. This one would be the log of 5 cubed. Let's just write 125 plus the log of 2 cubed, 8. Oh, and I recognize that as the log of 1,000. And the log of 1,000, since it has 3 zeros, is a 3. So maybe you don't know that yet, but the log of 10 would just be 1. The log of 100 would be 2. And the reason why is because, well, the base is 10, and 10 squared is 100. So 10 to the third power, because I'm asking what's the y value, what can I raise that to? What is that exponent? So however many zeros there are in that, and then that kind of helps me with this definition. The log of 1 equals 0. And then be careful, the log of 0 is actually undefined, because if you look at the log function, its graph looks like this, and you're actually undefined at x equals 0. So you can only take the log of positive numbers. This is the log of a minus the log of b, so we'll write that as a quotient. X minus 4 equals 1. The base just gets carried along with those properties. Then I'll fishhook this, so 5 to the first equals x over x minus 4. And then I'll do cross multiplication and divide. So this simplifies to 5x minus 20 equals x. Subtracting off x and adding 20, and x will equal 5. This next problem we're going to be using our calculator. Again, it's really important that you go out and get a TI-84. You can use it on your exams, and I'll be testing if you know how to use your calculator to find roots or solutions. And I'll show you an example of that here. If I try to solve this by using the dump up property, the log of x cubed minus the log of x to the 4th, notice the bases just drag along. I don't even worry about the bases when I do those properties. But I need to keep them because after I do the definition, I need that base. The log of a minus the log of b is the log of a divided by b. Notice the base again just drags along. But now I'm going to get rid of the base by doing the definition of logs. 2 cubed, which we know is 8, is equal to x cubed over x plus 4. And when I do my cross multiplying and dividing here, I'll get 8x plus 32 equals x cubed. I could set that equal to 0 and try to factor, but there are not factors of 32 that differ by 8, so that's not possible. You can't use the quadratic formula because, what is it, negative b plus or minus the square root of b squared minus 4ac, because it's not a quadratic, it's a cubic. So the method that I want to use here is go to your graphing calculator, graph it, and then find the roots. Let me show you how. Go to your y equals, and under your y equals, we're going to hit x caret up 3 minus 8x minus 32. Oops, I better try that one more time. Better come down, right arrow here, minus 8x minus 32. Glad I looked at that before I graphed. I'm going to choose zoom 6 because the first time you graph, you might mess up your window. So zoom 6 will set it back to a 10 by 10 by 10 screen. And then after it graphs, I'll hit second, calculate, which is a trace key, second trace. And I want to go for the zeros, which is number 2. And it says left bound. So I'll guess to the left by choosing, I'll use the negative, not twice, but just once. Oh, negative 3 is fine. Anywhere to the left I can see is negative 3. I'll use a 6. Oops, negative 3. I'll press enter. I see a vertical line that comes up at negative 3. I'll press 6 for my right bound, and then I'm going to guess that it's at 4. And in this case, I'm right on. I can see that the y value is 0, and so this answer was nice, no decimals. It really is just x equals 4. There's another way to have done this. You could have done synthetic division. If you remember how to divide synthetically, we'll review that again later. But looking for zeros here, by doing that rational root theorem, p divided by q, I would prefer you not do that. I want you to use your calculator. Again, check Blackboard for solutions to make sure you're getting these answers correct. This one, I'll fishhook to undo the log. So 2 to the 4th, which is 16, is equal to 8x plus 24x squared. I'll try to set this equal to 0. Wow, my pen is really just flipping out on me here, so sorry. Plus 8x minus 16. I'll try to divide everything through by 8, just to make the numbers a little bit smaller. So what is this? 3x squared plus x minus 2. I'll try to factor this. Looking for factors of 3 and 2 that differ by only 1. I think I'm going to go 3x and x. And differing by 1, I got to put a 2 and a 1 here. Sign's going to be different. The larger is positive. However you factor, I just guess and check. So the larger is my outer terms. I need to make sure that's positive. Inner is negative. So x is either 2/3 or x equals negative 1. But remember, you can't take the log of a negative number. So I'm going to check that negative 1. If I throw a negative 1 in here, I think I'm okay. It's positive. So, and I think I'm okay with the 2/3. So I would put in solution set. 2/3 is a solution, and negative 1 is a solution. Go out and buy a new pen. It's driving me nuts, and I'm sure it's driving you nuts too. The log of a minus the log of b is the log of a divided by b. Wow. If you have the log of the left side is equal to the log of the right side, you can just literally drop the two logs. So 2x plus 5 over x is equal to 3 over 1. I'll cross multiply and divide again. So this diagonal is equal to that diagonal. And, x equals 5. The log of a minus the log of b is the log of 2x plus 5 over x equaling 3. If I don't write the base, remember it's a 10. So 10 cubed is 1,000. And I'll get 1,000x is equal to 2x plus 5. 998x is equal to 5. And x is equal to 5 over 998. I think you'll be okay for the rest of these. I don't see anything too out of the ordinary. Alright, I'll just do one more. I like this one. The log of a plus the log of b is the log of xa times b. Hope I can read my own writing here. Equals the log of 3. And so this is the log of 2x squared plus 5x equals the log of 3. And again, I can just drop the logs, set it equal to 0, and try my hand at factoring again. So I know I've got to choose 2x and x. The only factors of 3 are 3 and 1, and I need them to differ by 5. So I'm going to choose 6 and 1. There's my outer term, 6 and 1. Larger is positive, so I've got to make this plus and that a minus. And lo and behold, x will equal 1/2. Or x will equal negative 3. And am I worried about the negative 3? Yes, I am. That negative 3, I can't plug that back in. It won't check. So that's called an extraneous solution. You throw that away, and the only solution I'm going to have left is 1/2. And we can put that in solution set form. I hope you can use the handout and finish off the rest or the remaining log problems from this video. I won't do that from the video, but you can do it from the handout and check the answers on Blackboard. If you have questions, email me. Thanks.